already? Okay.
I just-
All right, so what do we always want to do in these problems? We have a whole bunch of text. We want to write down exactly what's going on, right? And try to figure out a way to deal with it, right? A way to sort of to dive into our problem. So here we have the flies, right? We're not told what's dominant, recessive, right? What are we told? We are told that a little w, right? Little w gives you what? White, right? So I want to write that down. Little y gives you yellow, right? And is there anything else? We have a mutant strain of homozygous for the Y-eyed mutation, mating of a white-eyed fly with a yellow-eyed fly, right? So here we could go a white-eyed fly, right, with a yellow-eyed fly, right, mated together gives you what? Our data, right? So let's say it gives us our data. Okay, so you're crossing those two and you're getting your data. This is a dihybrid cross, right? Or no, it gives you the F1s, right? Mating white-eyed fly with yellow, that gives you a wild-type fly. Oh, yeah, sorry, I got one step ahead of myself. So you make those two, right? You make these. What is the genotype of the F1 thing going to be? Big W, little w, big Y, little y, right? What does that tell you? What does it tell you about the phenotype here? What is it? It's the wild type, which is red. Okay. So red, dominant, red. So now when you make a big W, big Y, right? Big W, little w, big Y, little y, then that's when you get your F2s over there, those ratios. Okay, so here are your F2s. You see that a dominant is red. You look at this genotype, that you get 92 individuals, right? So you add all of these together, right? What is it? 5, n equals 5, 12, 165, right? If you just kind of squint at it, right, what do you see? What sort of ratio do you see emerging? Here's your 16, here's your 9, 3, and 4. So a hypothesized ratio would be 9, 3, 4. This is a combination that gives us the 16, right? So that indicates that, epistasis may be going on. Could we test this? How could we test this? And this would be another, what would we expect? We could test it to see if our ratios are close enough, and that's what we're going to do in lab, right? How do we test observed versus expected? What statistical test do we do? Chi-square test. So you could even go through here, 9/16 times 165, and get an expected number here, get an expected number here, expected number here, and do a chi-square test. But we're going to just squint at it, and we're going to say, okay, this is close enough. 9, 3, 4 ratio. Epistasis is going on. Okay, so what is this telling us? It's saying how many genes control for eye color? 2, dominant recessive interaction for the alleles in each of those genes, and they're assorted independently. Is epistasis going on? Yes. Where is epistasis going on? We want to figure out the genotypes, right? We already kind of know the red genotype, right? What's the red genotype? I'm going to erase this. I'm going to do genotypes here. What's the 9 genotype? We already have it in the F1s, right? What is that? It's big W, whatever, big Y, whatever. Do we know the white? Because we have the 9331. Where is the recessive? It's in the 4 part, right? Because that's a combination of a 3 and a 4. So that we know is going to be little w, little y, little y. We know here, right, that the yellow is little w, big Y something. So we have this one, little w, big Y something. And then now the 3 part of that one is big W, whatever, Oh. Yeah, let's switch these. So this is big W there, little y, right? Because that was the yellow one, right? This is our white-eyed, and that was, we just mixed it up. This is our yellow one. This is our white-eyed one, this is our yellow one. And so now, the 4 part then becomes the big Y, whatever, little y, little y. Okay, so now we have our genotypes. These are our 9, 3, 3, 1 genotype. Can we draw an epistatic pathway for that? What do you think? Where do we start? We know the 9, right? We know the 9, it's there by itself. So we say, okay, here's red. We know it has to have both of those. Where is the 3 going to be? Where is the yellow? Are we going to go white to yellow or yellow to white? We're going to go, and sometimes you can just do this by trial and error, right? So we see that if there's no products, what is it going to be? Little w, little w, little y, what is it going to be? Where the 1 is, oftentimes is over here on this side of the pathway. So let's try that one first. White here, yellow here. What gene product gets you to go from white to yellow? Over here, a big W, right? So you just go big W here, big Y there. Both of those give you red, one of those gives you yellow. If you have either little w, little y, you get white. If you have little w, big Y, or Y whatever, you still stay to white because you don't have the enzyme or whatever it is that's going to convert white to yellow. Okay, so there's that pathway. So there's that problem.